Okay, this is part 2 of our chapter 8.2 on two-step algebraic equations. We are on question 7C, which says half of a number plus an additional 1 and 2/3 has a standard value of, or has an equivalent value of, 1/6. So with this question, there are two things you can do. Now, obviously, the first thing you're really going to do is convert that mixed fraction into improper. So we're going to go 5. This is 7C. This is where we're at, right? Am I wrong? Okay, 7C. So the first thing you do is convert that improper mixed fraction to improper. And there are two options. You can pursue option 1, which is to subtract 5/3 from both sides. And that's okay. You have half of a number will equal, find your equivalent fractions. 1/6 take away 9/6 is negative 9/6. Then you're going to multiply both sides by 2. And since you're multiplying a fraction by 2, usually it's good to remind yourself that that whole number is really a fraction over 2. Look for cross reduction. 2/6 could reduce down to 1/3. Oh, and look at this. And now, negative 9/3 can reduce down to negative 3/1. So really, I end up with just being n equals negative 3. Now, if all that hullabaloo confused you, I can go back to where sugar cubes. I can go back to the original part right here, and without cross-reducing, I could simply multiply the numerators to get negative 18, multiply the denominators to get 6, but negative 18/6 can be reduced down to negative 3. So your answer for question 7C, if you did it by utilizing fraction sense, you got the answer n equals negative 3. In question 7D, you have the question 4/5. Take away 2.5 of a number is equal to 3/10. So the first thing I would do is I'd rewrite this particular take away 2.5R because I really don't like it in that form. And I would probably write it as either 5/2R, or even better yet, since 5/2R means 5/2 multiplied by R/1, I would multiply the numerators, multiply the denominators, and I'd get 5R/2. So this, and this are all the same thing. This one right here is probably a more convenient way of looking at it, but you don't have to write it that way. You can keep it 2.5R. So we're just going to go back and keep it as, sugar cubes, 2.5R, and I'll just erase this error. Okay, so the first thing you have to do is identify the constant, and in this particular equation, 4/5 is your constant. So I could subtract 4/5 on both sides, and then divide both sides by negative 2.5R. But for this question, we're going to try it the other way, the simpler way. So again, I'm going to change this 2.5R actually to 5/2 because I like having them as that. So what you can do here is, instead of subtracting 4/5 from both sides to get rid of the constant, we're going to apply this other idea of multiplying both sides by a common multiple of the denominator. Since we have a binomial over here, and we have a monomial over here, and the denominators are 5, 2, and 10, any multiple that they share in this case 10 is the lowest common multiple they share. If I multiply both sides by 10, the idea of maintaining equality, and what I mean by that is, if I consider the equation to be a scale, if I multiply this side by 10 and this side by 10, I maintain equality. So if I multiply both sides by a common multiple of the denominators, in this case 10, I will maintain equality. But since this is a binomial, we have to remember to expand, and both terms must be multiplied by 10. So what I'm going to do now is rewrite this as 10/1, or 10, multiplied by the 4/5. That's the first one. And then 10/1 multiplied by negative 5/2. And I'm going to just keep this negative sign with the actual term itself, negative 5/2R, or negative 5R/2, I suppose is a better way to even think of it still. we're going to put that variable in the numerator, like I said before, is equal to, and then I can really just keep that as is because I'm going to cross-reduce that anyway and get 3. I'll put 3 here because I know that's what it's going to be. So if you don't cross-reduce, you're going to get 20 over 5, which will end up being 4. But if you cross-reduce, oh, excuse me, not 4, sorry, 40 over 5, not 20 over 5. You would get 40 over 5, which would be 8. But if you cross-reduce, 10 over 5 will become 2 over 1. Multiply your numerators, you get 2 times 4, which is 8 over 1. No matter how you slice it, that first expansion, or 10 times 4/5, is going to be 8. Then if you cross-reduce here, 10 over 2 is going to become 5 over 1. 5 multiplied by negative 5r is going to become negative 25r. Okay? Equals 3. So what we've done by multiplying both sides by 10 is we've created this much simpler two-step algebraic equation that doesn't have any fractions. Get rid of my constant by subtracting 8 from both sides. You get negative 25r equals negative 5 because the sum of 3 and negative 8 is going to be negative 5. Divide both sides by your coefficient. And the r will equal negative 1 over 5. When you reduce this down to lowest terms, negative 1 over 5, or if you want to do a decimal, r will equal, positive, not negative. So negative divided by negative is a positive. Negative 0, or positive 0.2 is your answer. Or positive 1/5. That was a lot of work for one question. Question number 9, correct? Did we do 9? Question number 9 is a lot easier than question number 7, because instead of using fractions, question 9 is using decimals, which of course is the same thing. So what this really would say if it was fractions was x divided by 6/10 plus 2.5 equals negative 1. That would be the same question if it was written with fractions. But of course it's not. It's written with decimals, which is much easier because you just use a calculator. So here we're going to subtract 2.5 from both sides. X divided by 6/10 is equal to negative 3.5. Multiply both sides by 6/10 to get rid of your dividing by 6/10. Grab your calculator. Square it to the computer screen so you can see it. 3.5 multiplied by decimal 6. I don't need to worry about negative and positive signs because I know my answer is going to be negative because a negative times a positive is a negative. Hit the equals button. It's 2.1. So for question A, 9A, this is 9A, the answer is negative 2.1. And the last question in question 9 is 9B. So 9B says 0.38 is equal to 6.2 take away r over 1.2. So this is your constant. I'm going to subtract 6.2 from both sides. I'm not real great at taking a positive 3.8 or positive 0.38 and subtracting 6.2 from it. So probably I would take my calculator and go 38 cents and a negative 6.2 is negative 5.82 equals. Now right now we have this. Given the options of either expressing it as this, or this, or this will be the method I choose because I know that I want to get rid of that 1.2. So I'm going to multiply both sides by 1.2. That's a 1. Negative 1.2, thank you. And r will equal, I don't need to worry about signs because I know that's going to end up being a positive product. Take my calculator, which still has 5.82 there, multiply it by 1.2, and you end up with 6.984 as your r value. Question 11. Again, simple, not a hard question at all. This is question 11A. 11A. So our constant's 2, so we're going to subtract 2 from both sides. If you have 55 cents but you owe $2, you're going to really owe $1.45 when you pay off as much of the $2 debt as you can with your 55 cents. So you end up with 12.5 V equals that. Divide both sides by your coefficient. And when you grab your calculator and go 1.45 divided by 12.5 and press the equals button is 1.66. Remember, it's a negative divided by a positive, so it's going to be a negative 0.116 equals V. And finally, 11B, you owe 77 cents, and that's equal to, oh, I don't even know if we can contextualize this one. I can't. First thing I do is add 45 cents to both sides, or 4,500 if you want to think of it that way. If you owe 77 cents but you have 45 cents, you can't pay off all your debt. But when you pay off as much as you can, you'll still owe 32 cents. So negative 0.32 equals negative 0.1x. Ignoring signs because I'm going to divide both sides by a tenth, a negative tenth. So I know my answer is going to be positive. If you have 32 cents divided into piles of 10 cents, if you have 32 cents divided into piles of 10 cents, you can make 3.2 piles, which is 3.2. If you didn't believe me, you can take your calculator and go, what is 32 cents divided into piles of a dime? You can make 3.2 piles. So x equals positive 3.2. Question to 13 is a pizza question. It says the cost of a pizza, this is question 13 on 8.2. The cost of a pizza is $8.50 plus $1.35 per topping. So the first thing you do in this is define what you're looking for, how many toppings. Define your variable. So T will equal the number of toppings. So if it's $1.35 per topping, it's going to be 1.35 multiplied by the number of toppings you have on your pizza. Plus, no matter how many toppings you have to pay a constant amount of $8.50 for your pizza. And that total, meaning the cost of the pizza plus the toppings you buy, is going to be $13.90. Okay? So algebraically speaking, and I know it's probably easier to solve without doing it algebra, but algebraically speaking, this is an equation that represents that. So how many toppings are on a pizza that costs $13.90? We'll subtract the cost of your pizza. And you'll get $1.35 times the number of toppings you bought will equal $5.40. Divide both sides by the cost of a topping, and you will find that T equals 4. Circular answer, and the last thing you should write for a story problem is this beautiful 3-dot therefore symbol. Therefore, there was 4 toppings on the pizza. Perfect. Question 14. Hiroshi paid $34.95 to rent a car for a day. So Hiroshi paid $34.95 to rent a car for a day. That's what he paid. Plus 12 cents per kilometer. At the end of it, when he paid his bill, the cost was $55.11 before taxes. How much did he drive? So he paid this amount regardless of how far he drove. This is going to be the constant in your equation, because no matter how far he drives, you're going to have to add that to it. And it's 12 cents per kilometer. So X will equal the number of kilometers he drove, number of kms he drove. So multiplying the number of kilometers by 12 cents and adding the rental cost of the car of $34.95 will equal the before tax price of $55.11. Subtract the cost of renting it. 12 cents a kilometer will equal $20.16. Is that right? Everybody right with that? I don't know. Is that right? Anybody? Sure. Why not? Divide both sides by the cost of a kilometer. Grab the calculator. $20.16 divided by the cost of per kilometer tells me, ooh, wonderful, X equals 168. Circle your answer and put your therefore symbol. Therefore, Hiroshi-chan drove 168 kilometers. All right. Question number 15. On Saturday morning, Mark, who spells his name with a C, interesting, had a quarter of his weekly allowance left. He had a quarter of his allowance. I don't even know if kids get allowances anymore. I don't know if that's really a thing anymore. So Mark had a quarter of his allowance left on, this is question 15. He spent a total of $6.50 on bus fares after he had his quarter of allowance, and he bought a freshly squeezed orange juice. So he paid $6.50 for the bus fare and the freshly squeezed orange juice. So he paid $6.50 for a bus fare and some OJ. And at the end of the day, after he had a quarter of his allowance, he still had $2.25 left. All right, so X is going to be his allowance, because we want to know how much allowance did he really get. So if he had a quarter of his allowance, there are three ways you can write it. You can write it that way, you can write it that way, or you can write it that way. All three ways are correct. Since we do have decimals here, probably the best way to write it would be this way, because we're maintaining continuity of all of our terms, and we're going to keep them all decimal. So given that all three are correct, I am going to keep this one as my first term, a quarter of his allowance. A quarter of his allowance, not plus, take away the cost of his bus fare and his OJ. So a quarter of his allowance, which he started the day with, take away the bus fare and the allowance, he still had $2.25 left over. So there's your equation. So before he paid for his bus and his expensive freshly squeezed orange juice, you could add that $6.50 back on to see how much he had before he bought those things. So the quarter of his allowance would have equaled $8.75. And if a quarter of his allowance was $8.75, then multiplying both, or dividing both sides, by a quarter. And remember, dividing by a quarter is the same thing as multiplying by its reciprocal. So if you divide a number by 0.25, some people will say, well, why would it be bigger? Because dividing by a quarter is the same thing as multiplying by its reciprocal. So when you divide by a quarter, you're really multiplying this amount by 4. So when you take your thing here and go 8.75 divided by a quarter, or multiplying by 4, you get $35. So X equals 30. Who gets a $35 allowance? That's ridiculous. Does anyone get an allowance in here? Anybody get an allowance? Not one person in grade 9 gets an allowance. That's hard to believe. Most people have jobs. Is that what it is? Okay. And the last question was question 16. It says, we had to do 16 or just to 15? Do we have to do 16 too? Yeah. Okay. So it says Nadia had a summer job in an electronics store. She is paid $400 per week. So right off the bat, $400 per week is going to be what part of your algebraic equation? She's going to get paid that no matter how many hours she works. That is her constant. This will be your constant because it doesn't change as the number of hours changes. She gets paid $400 per week, plus she gets $5 commission, 5% commission, 5% on everything she sells. So if she sells a $100 TV, I guess you don't have TVs that are $100, but if she did, she would get 5% of that, which would be $5 on every item she sells. So at the end of her week, she earned $510.30. So she earned $510.30 in a week. So first thing we're going to decide, X equals total sales by her. So 5% we're going to represent. So 5% is 5 over 100. which as a decimal is 0.05. So 5% is 5/100ths, which is 0.05. So really, 5% of her sales is 5% of her sales, and 5% multiplied by X, is really a coefficient. So we have 5% of her sales, plus the $400 she receives if she didn't even sell anything. And at the end of the week, she had $510.30. Subtract that $400 off, and you would have the 5% commission she had on her sales equal to $110.30. Okay. So again, here we're going to be dividing by a decimal, which dividing by 5/100ths, when I divide by 5 is the same thing as multiplying by the reciprocal. And the reciprocal of 5/100ths is really the number. I'm really going to multiply what she made by 20. When you divide by 5/100ths, you're really multiplying by 20. So you take the number, so $110.30. Oh, that's not 110. That's 110.30. Divided by, oh, that's not it either. I'm all discombobulated. Equals 2,000. Oh, I forgot. $2,206. Is that 2,000? Oh my God. Yes, $2,206. So therefore, Nadia sold $2,206 that week. Now the second part says Nadia's average earnings are $780 per week. What are the average value of her weekly? We're not going to skip that part. We're going to skip that. We're good.